Okay, so I am going to start the crash course on the web. Some of this is probably review for those of you who have taken either the full stack course or the cloud course, yet I don't have a formal prerequisite for this class. So I'm going to go through it, and you can go and do your homework on the side if this stuff is known to you already. So the basics, you have web clients, you have a protocol, HTTP, and you have web servers, and that gives you web applications. And this is what it looks like. Your client on the left, the protocol over the wire in the middle, and then the server on the other side. And you see how old this graphic is. It has Apache here, an old version of the Apache, but this stuff hasn't changed that much. So we'll start with the clients, go through some terminology. The web page consists of objects. Every object in the web has a URL, consists of two parts, the host name and the path name on that host that the resource is located. And typically you have a page that's a base HTML file and then several referenced objects that are within it. The client's really simple, retrieves the content from the web server, HTML and images, and then retrieves and executes any associated JavaScript, and then it executes the JavaScript on those static elements and renders you a page. Okay, so some examples of web clients. Typically you're using a web browser, Chrome, Firefox, Safari, Brave, whatever your browser of choice is. We'll also be using command line tools in this class. So curl and wget are two web clients that you can, interactive web clients that you get via the command line. And then we are also going to do programmatic access using Python requests as a web client. So you'll be able to program things like headers, cookies, login form submissions using Python. That's the other part of this class. So really basic. So here's some on the left is some static HTML. HTML is a language that just describes what something is, and it doesn't execute code. So it's a really safe format. JavaScript is on the right, which is completely different. This is basically code execution. So most web pages contain both. And so here's an example where the JavaScript is embedded as a script in line with the HTML, and then it executes some kind of function. And in this case, it pops up an alert box with the number 11 in it. If you have taken any security course from us, you will realize that this is a very alarming pattern where you're mixing the code with the data together in one package. So this is a recipe for vulnerability in any kind of instance. So for CS495, you're mixing the text segment with the data segment, and you're allowing code execution to happen on the data segment, which is causing you a complete jailbreak. Likewise, with the web, you have your static elements, and then you're executing code right alongside of it. So, for example, JavaScript can be used to get your documents cookies and to send those cookies somewhere else. And that would be the mixture that is problematic whenever you have these kinds of formats. Another example is a Word document that has macros in it, right? You have this static payload, you have a macro that's a program, and you can use that program to exfiltrate all the data on the person's hard drive, for example. So that's never a good thing. And so I cannot overstress how important knowledge of JavaScript is to web security. Everything is running JavaScript except my sites. Because, well, I'm not that good of a JavaScript programmer, and most of my stuff is static. But you can see that everyone's using JavaScript in their packaging. And as it turns out, when you create a web page and you start using some libraries of JavaScript functionality, turns out I would guarantee that you don't ever go back there and update that thing when new versions of that JavaScript library get deployed, like, for example, security patches. So we have all of this code that we deploy once and we never check. So that's one of the issues with JavaScript. Did you have a question or no? All right. Okay, so the problem is getting worse. We have this surface area problem, and this is what we talk about a lot in security, is how big is the surface area that you're trying to secure? And it turns out, with all of these newfangled web applications, it is enormous. Like the amount of lines of code, of JavaScript code, and this like stops in 2016. The amount of code that a website depends upon is huge. And so within the last year or two, people have really become concerned about the supply chain attack. What happens when code that you depend upon falls into the hands of a nefarious actor, and then they're able to change it in a way that allows them to compromise running sites? Okay. So in this class, you will be monkeying around with a lot of the elements of a web page. And to do so, you're going to have to familiarize yourself with your browser's developer tools. Control-Shift-I is the keyboard shortcut to pop up the developer tools. So if you have a laptop, you can play along. I want you to visit the homework site at CS495 OregonCTF.com. And I'll show this here. Just to give you some bearings on what's going on. So this is the developer tools on the right. And if I go to, and up at the top, there are the different page elements of the site. I hope you can see that. Unfortunately, I don't think developer tools will magnify. But if you look, you have the elements of the page. You have a console that allows you to type in JavaScript commands in the context of that page. You have the different sources that were downloaded to render the page, and that's over here on the left. You have the network requests, and I need to have this up to do the network requests, so I'm going to do a 495.OregonCTF.org. You have all the network requests for this page. So you see I have this base page here, and then the embedded contents here in the network graph. And then these are the different sub-requests that will be retrieved in order to render me the login page. The other thing is in the application tab, you can see all of the different things that the application stores in your web browser. The thing that we're going to be interested in are these things called cookies. Right now there are no cookies, but there will be soon. You can get the security credentials of the site, and of course the page isn't secure because it's not protected by a certificate, but other ones will be. So one of the things that you can do, and you'll be doing this a lot for the homework site, if you want to inspect an element on the page and you want to see what it's meant to do. So for example, I want to know what this submit button is going to do when I click it. I can right-click the element and I can say inspect this thing. And then within the developer tools, it will highlight the HTML that is used to render that button. And all throughout the elements, as I go up and down, it'll highlight the thing that I have, the associated element in the page that I am looking at. And so in this case, if you look at this button, submit, it is enclosed in a form, and I'll talk about forms later, that when you click it will result in submitting a post request to a path called login. So this is just something that will become hopefully very natural to you as you start navigating these sites. What do I want to show you here? Okay, console. The console, I don't have a cookie, so I can't do this, but here, I'll show you the cookie later. What else did I want to show you here? I think that's it. Well, I can do something like this in the console. I can execute arbitrary JavaScript to interact with the elements on this page. So if you want to test out some JavaScript functionality that you want to add to the rendered page, you can do that interactively via the console. Okay, so that is that part. I think I showed you everything I wanted to there. Okay, the next thing I want to talk about is HTTP. This is the protocol that's run between the client and the server. We're going to talk about the different headers, requests and responses, and cookies. So it stands for the Hypertext Transport Protocol. And this is the standard message format for communicating between the client and the server. It is a bidirectional TCP connection that goes from the client to a server, and more specifically on that server, it's port 80 on that server for clear text HTTP. The idea is that when you have that connection going to the server will accept the TCP connection request, establish that connection, and then send messages back and forth in a specific format, the HTTP format. All of the messages in HTTP are encoded in text, clear text. And it's important that a lot of these protocols are human readable. For us, if it was a binary protocol, we'd be hating it, because then we'd be like, oh, I got to parse every single message. So they made this human readable for us to be able to, well, for debugging purposes. And that's traditionally what a lot of the internet protocols have adopted, is a human readable format for analysis. If you really care about performance, this is terrible. Like, imagine sending an image using ASCII text as your carrier protocol. It turns out you're wasting several bits of the payload all the time. So you'll see that other kinds of protocols go to a binary data transfer format. Okay, two kinds of messages in HTTP. There are the request messages that the client sends to the server, and then the response messages that the server sends back to the client. So in this case, if I go to this URL, someschool.edu, some.dir, and page.html, what happens is that the client makes a request to the IP address of www.someschool.edu, connects up to that port 80 on that address, and then the first thing that it sends the server is a request line. And the request line has three things in it. It has a command, and in this case, this is a get command. A get command says, I just want to retrieve some object. A post command says, I want to send you some data. So that's the difference between get and post. There is a head command. There's actually there's like a dozen different commands you can send. The only ones that we care about are these three. There's a head command that says, give me some information about the object I'm about to access. Like, did it get, like, when was the last time it was modified? And the reason why the head command is there is so that for caching, for example. So you don't have to send the object back if it hasn't changed. The next part of the request message are a bunch of headers. So these are pieces of information that the client wants to send to the server to specify things like, what language do I want back? So if I'm hitting a site and I only speak French, and the site has support for multiple languages, by sending the language that I want to accept French, that site can turn around and give me the French version of that site. Another important header field is the host name itself. So in this case, because we're trying to get www.someschool.edu, I have to tell the server that I want that particular domain. Now, the issue here is that when you connect up to the web server, you're connecting up to its IP address. But that web server could have multiple domain names associated with it. And so it could be hosting a dozen different sites. You have to tell the web server running on that server which site you're looking for. And we'll see this in later examples. And then the user agent, what browser am I using to access it? And then finally, you get a blank line that indicates the end of the headers. And then if it's a post request, you'll have, for example, form submissions are done with post requests. You'll have the data in the form fields that will be attached as the rest of the payload. So you send a request over to the web server will process that request and send you back a response. And so what the server sends you, it sends you a status line, and it's got three things in it. It's got the version of the protocol that you're using, and it's got a status code. And this is a small integer that it sends back, and then a text description of what that status code means. And so in this case, the OK status code, the 200 OK, means that I successfully retrieved that object. And then I have a bunch of server header lines that talk about, what server version am I running? When was this object last modified? What is the length of the payload I'm about to send back? What is the content type? And so the server needs to tell the client the kinds of content that it's sending back to it so that the client knows how to render that thing. So for example, if it's an image, it says, you know, hey, this is an application PNG. And then the browser is like, oh, well, I'll call the PNG renderer in order to render that image. So that's done with this content type field by the server. Yeah.
These headers, now this is the application level header, right?
Yeah.
Okay.
So this is what
in
Nginx or Apache will typically say, hey, if it ends at .png, I'm going to send this content type header when I send a file back with that suffix, that file name extension. So it's typically hard-coded in the server software itself. Now, if you are programming a web app and you're using either Node.js or Python Flask, you can set that header programmatically. So in the cloud class, we generate a blurred image in the cloud class, but then we're like, well, we have to send back the actual content type because it's not a file name that exists on the server. It's actually some blob. And then we're going to send that blob back to the client, but we have to tell it what is the content type of that blob. And that can be done programmatically if it's not a static file sitting on the web server. Okay. Any other questions about the mechanics of the requests and the response? This is my last request to you, so close the connection down after you have sent me the object. So this is something I also cover in the cloud class. Sometimes, if you get the base page and you know you're going to get 10 more objects from that server, the embedded images, you say, keep that connection open because you're about to get 10 more requests. At the end of if you know this is the last object of the thing that you're going to download, you would send the connection close header. That's not a security issue in this class, so I'm going to skip it. You won't be monkeying with that header in this class, but that's what it's there for. This is for persistent connections. So it basically reduces the overhead on a web server if you're not continually. So if I have a base page and 10 objects, that's 11 requests. If it's done over a single connection, the server is happy. If you actually make 11 requests, the server is very unhappy. And so that's what the protocol header is for HTTP 1.1. And if you're really interested in this, I can point you to a screencast about why this is being done this way. Okay, and then that's followed. So after you specify all the headers, you have a blank line, and then the payload is emitted after the fact. Okay, one of the things that you saw in this the first status line was a integer code. So HTTP has these numeric codes, and the first digit of every code specifies the kind of status type. So the 200 series are the request is successful. So there's actually, you'd normally just see 200, and that says your request succeeded. But you'll get all these other error codes that can get sent back. You'll get a 302, and the 302 says that the page is moved. Or the 300 series say something happened, the request was successful, but something happened. And then in this case, the most common thing you'll see is that, you know what, this resource has moved from its old location to a new one. Here's the URL for the new location of that resource. And you might have seen this. You go to a link that someone has sent you, and then it redirects you to some page that, because it doesn't exist anymore, it redirects you to the home page. That's done with a 302, typically. The 400 series means there's something wrong with your request. The server isn't able to process it at all. So the most common one is the unauthorized one. So if your permissions aren't set right on the web server, or if the object doesn't exist, say you made a typo in your HTML, then you'll get a 404. So the 401 means that you don't, the server can't access it, doesn't have the permissions. The 404 says it can't find it. And then the last set of codes are the 500 series, meaning that something happened on the server that caused it to crash. So if you were in the cloud class and you built a buggy Python app as your web application and it crashed, you would get a 500 error on the client back from the server. Okay. So you can use Netcat to see these headers in action. So in this case, most of my servers, so Mashimaro, which is my site, which is running the Oregon CTF homework site, and then the course website, it's running everything. It's like the family jewel, so if that thing gets ransomwared, I probably have to pay a lot to get that thing back. I have a backup, but hopefully they don't encrypt that thing too. But this is running all the websites that I've run, and so I'm going to show you how an interaction with this server can get you different pieces of content from it. It hosts these two domains, chini.com and then thefengs.com. And then I'm going to show you the headers. So I will speak HTTP. So if I do a netcat, and then I do HTTP 1.1, and one of the things you'll see if you've got good eyes is that here I get a 301 error that says this thing has moved permanently, and it gives me the location of the new resource. And so what you're seeing is that I have configured this domain to only allow secure connections to it. And so when I connect up to the plain text port 80 version of this website, it gives me a status code that says redirect to HTTPS, which is the HTTPS version of the site. Okay, so and then the browser knows enough to redirect itself, is programmed to take a 302 and then visit the other site. Okay, so that's an example. Whereas if you did something like this, you go to the same site. So if you recall, I'm running multiple sites on the same server. You'll see that for this site is not configured to require HTTPS, and you'll get a 200 OK, and you'll get some HTML back. Okay, and then you can parse these headers to figure out. In fact, adversaries do. They parse the headers and say, what version of Nginx are you running? What version of Apache are you running? Is it vulnerable to any kind of exploit? So that's part of the reconnaissance task, which we'll get to towards the end of this class. It's like, how can you automate finding vulnerable stuff on the network? Well, this is one of the things. This is called fingerprinting a server, where you go and poke around and see the kinds of headers that it returns. And so you can see the server version, Nginx 1.14.0. You can Google it to see if there are any CVEs against this version of Nginx, and then you can get access to it. Hopefully not, but you could if there was. Okay, so that is what I wanted to show you there. So two different sites located on the same server. I can actually show you. Do I have this on here? I can actually show you how this is set up. Actually, I have a different part of this lecture where I show you how this is configured, which I will skip that for now. Make sure I'm doing okay. Okay, so I'm going to now go through a bunch of the different headers that are germane to our class that HTTP uses. The first header is the referrer header, and this is a request header that the client sends to the server that tells the server what page the client was on when it made the request to the server. So this is really important for privacy issues. Because when you go to a site that's got a Facebook icon on it for liking this page or whatever, what happens is you visit CNN.com and it's got that image that's hosted by Facebook. What Facebook gets is that you have viewed CNN.com because the referrer header gets sent to it when you retrieve the embedded Facebook icon. So that is done with an HTTP request header. And this is what it is, the referrer page. And to show you how this works, I'm going to access a Prezi. So Prezi is a presentation site that I use. I'm going to access it through a different link. So we run a summer camp every year called CyberPDX. So this is the site for CyberPDX, and I have a bunch of prezzies here. So here's an encoding one, ciphers, and etc. So if I bring up the console and I go to the network, what I can do is if I click on Prezi, so this is an encoding Prezi, you see that it goes and it accesses a whole bunch of resources. If you go up to the very first resource, if I can, wow, did that just crash my browser? No, it didn't. It's just slow. I need a new laptop. Oh man, let me scroll. All right, so this is the initial request. When I clicked on that encoding link, this is the initial request, and you can see as part of the request headers down here, well, you probably can't see it because it's too small, but if you click on the request headers, you should see, wait, you don't see it. Where is my refer? Maybe it's on the next one. All right, I'm going to try this again. If this doesn't work, I am going to have to stick a fork in it. You should see the refer. So that is the kind of request header hacking that you can look at to see the headers that are being passed from your client to the server. Now, there are ways, if you look at these extensions that try and preserve your privacy, they would filter that out. They would say, you know what, I don't want to send that information to the backend. So now Prezi knows that this Prezi was accessed from my website. Okay. Okay. The next set of headers that are really important are the cookies. So initially, HTTP was stateless. It didn't remember prior requests from the current request. But if you want to build an e-commerce application, you need to be able to accumulate state for a user. So when a user adds stuff to their shopping carts, you need to be able to associate a session to that user. And so almost every single site requires and needs you to store state. And so the way this is done is in 4 steps. The first thing that happens is on the server will generate a thing called a cookie, and it's typically a random string that is generated on that's not predictable on the back end. And then it stores this random string, this cookie, into a database and associates it with the particular session that it's currently processing it. And then what it does is it says, for that session, I am going to send an HTTP response header that tells the browser to store that random piece of data. So the server is asking the client to do this set cookie operation. And what the client does is it knows what site it's accessing that is currently accessing, and it stores this random blob in a directory associated with that site that it's accessing, so that subsequent requests to that site will attach this cookie in its payload. So So when the client gets this set cookie response header from the server, it will store that cookie in the browser, and then the next time that the client will access that same site, it will attach the cookie header, and then it will read whatever it stored for that site and then attach it as a payload to that header. So this is better seen graphically. So here is an example. You have a client on the left. It's already got a cookie for eBay, which is 8734. This is the cookie file stored within the browser. So when you are clearing your cookies from the browser, you're basically destroying that database. Yeah.
You say in the browser, like that's just somewhere in the directory structure?
Yeah, there's local. Every browser stores information differently. I think it's like a SQLite 3 database in Chrome. In Firefox? Okay, so it's all SQLite 3 in there, and yeah. And then when it makes a request to the server creates an ID for that particular request, or creates a cookie, a random cookie, so in this case 1678, and associates it with that session, and then stores it on the backend database. So for example, if this particular user ID has started to accumulate items in a shopping cart, that gets stored in the backend database, indexed by that random number, and then it will send back the set cookie response header. And this 1678 is the unique random number that the client then stores. So say this is Amazon, it associates with Amazon that random number. And then subsequent requests to Amazon, so say a week later you revisit Amazon, or if Amazon's got an icon on CNN, that cookie will be sent upon accessing that embedded Amazon image on CNN. That would also associate your access to 1678. And that will give you a cookie-specific action on the back end, because now you have associated your cookie. And then you'll get the response message that is tailored to you and your user. And then this persists, right? Like this cookie information persists so that over time, unless you explicitly delete the cookie. Okay. Okay, so the cookie attributes that we're interested in, this is the syntax of the set cookie field. And it's basically a bunch of key value pairs. And there are a specific set that are sort of standard. One of the things that it's standard is the expiration of the cookie. So, for example, if you're a bank and you issue a cookie, you want that cookie to expire quickly, right? Like if someone walks away from their laptop, like you want that person to have to re-authenticate to get a new cookie upon login. Otherwise, someone who steals the laptop will have full access to that bank account forever. So that's the expiration. And most banks are like either 5 to 10 minutes, and it's over. If you haven't done a request in 5 to 10 minutes to refresh that cookie, they'll wipe it out. They'll invalidate that cookie. The other parts are to specify the scoping of the cookie itself. So with cookies, you can programmatically determine where on the site they're valid for. So you could associate a cookie with just an entire site, but if you have subdirectories in your site that you want different cookies for, then, so you might have, on the banking site, you could have a cookie for the top level, but then to actually do transfers, maybe you want a different cookie to manage that kind of thing. So this domain and path are the things that target what subdomains of this URL is the cookie good for, and then what paths in that subdomain is that cookie good for. So this is just a programmatic way of targeting the validity of the cookie on a backend site. Okay. The other two that we're going to run into are the secure flag and the HTTP only flag. The secure flag says never send this cookie over an insecure connection. Because if you do, someone on the wireless network can see that cookie and pretend to be you. So if you are a bank and you're not setting the secure flag, that's a misconfiguration. So hopefully you can catch that kind of stuff and then be able to make sure all of your users are forced to use HTTPS to send their cookies. The other thing is an HTTP only cookie. And this says only send this within a legitimate full-on HTTP request. Do not allow JavaScript to send this cookie. And this will become important when we talk about cross-site scripting, where if I inject a rogue JavaScript script on your client session, I could programmatically access document.cookie, because that's part of the DOM, and then send it somewhere else. The HTTP only flag says, no, this only ever gets accessed and sent by the browser on a full-on HTTP request. So that's another important cookie attribute. Are there questions about that?
So for an HTTPS connection, if I'm say like monitoring the network, and do I even see the HTTPS?
Oh, you do see the initial setup, but as soon as we'll talk a little bit about how HTTPS works, but as soon as that connection has the TLS connection has been established, you won't see the protocol going across, the HTTP protocol going across. You will see the handshake, the TLS handshake happening, and then the protocol itself within the HTTP that's being carried within TLS. You won't see the GET request, you won't see the cookies, you won't see any of the headers. It's all encrypted and sent through that tunnel. But on the other side, when it gets decrypted, you can use standard HTTP processing software to process the connection. Yeah. Yes? Potentially. I don't know actually. So if you, well, that's a that's a cross-site scripting thing. If you have allowed, so we'll get to this, content security policy, cross-origin resource sharing. So if you have allowed, if the server sending you that page, so you're putting some trust in that server. If that server sending you that page has injected a script that causes a request to maybe a bank site, then I do believe that the cookie does get attached. Now, that's why visiting a rogue site would potentially reveal the cookie on that rogue site. So it's not arbitrary. You're only sharing the cookie to the intended recipient. We'll get to these issues towards when we get to cross-site scripting, actually. Are there any other questions?
I was just wondering, when we refer to, monitoring the network, are we saying like using like Wireshark or something else?
Typically Wireshark.
Packet sniffer?
Yeah, if you're in the wired network, there are these span ports. Like if you own the physical infrastructure, then there are ways of getting all the network traffic that's coming through you and then monitoring anything that's in the clear, you would be able to decrypt. But if you're in the network and someone has established an end-to-end HTTPS connection, there's not much you can do with that. Yeah. Any other questions about this? Okay. So one of the important things that gets sent in a cookie is the session ID. So PHP has this particular field that it sends in its cookies. JSP, Java Server Pages, has this JSession ID. For your homework site, you will see that the JSession ID is being used as a random token that identifies you in your session. And so I wanted to show this to you. There is, on the homework site, there is this default account, Ponelandia, and the password is CS495-595, which was your default password, but I forced you to change it. I made this account have that default password so you can get in there and access a different account. And so what I wanted to show you is an access to this page and then what happens and where you can find its cookies being stored. So I'll bring up the developer tools again. Oops. And then I will go to the site and you'll see the requests happen. So if you go to the application tab, you'll see that the site has given you a cookie. And so if you click on this cookie, you'll see the JSession ID. And that is authenticating your session with the backend so that when you solve something on that site, it can give you the flag that's for you. And then you can, get on the scoreboard with that solution. So that is being done with the JSession ID. And if you see, this thing starts with 54252. If I log out of this thing, where is this? Log out somewhere. Where is the log? Oh, I haven't logged in yet. So actually, yeah. Now I'm going to show you the cookie after you log in. Am I out of time? When does this class end? 11:50. I got 20 minutes. All right. You can see multiple other fields are given to you as part of this cookie. So you have a JSession ID, and this is what the backend server is using to identify your session. And this is actually considered good cookie design. There's nothing in there that gives you any semantic information about what's going on in the backend. We'll show you some bad cookie design. In fact, your Web for Pen Tester's got a bunch of bad cookie designs. This is considered best practices. So, and I would recommend you never design your own cookie system as a result of seeing these things. You had a question? No? All right. Yeah. Well, you'll see in your exercises, it's like the admin flag is there. You're like, it's part of your cookie. But yeah, it's good to see these patterns so that you know to avoid them. Okay, the other header that we are going to use is barely used in practice, but it's used for some of the sites that I'm having you do, so I'm going to show it to you. HTTP initially came with this thing called basic authentication. On a web server, if you plop down into a directory a file called .htaccess, and you specify a username password pair, what happens is the web server will use that to protect the resource, to basically password protect that directory. So this is not secure at all. This is some basic level of access control. And the reason why you should never use basic authentication is because when you understand the mechanism, you're like, that definitely isn't secure. The mechanism is similar to the cookie mechanism. The server challenges the client with this header, or an HTTP response header. It's called www.authenticate. And then this will cause the pop-up on your web browser that says, enter in a username and password, which you do. And then what happens is that the browser takes your username and password, it base64 encodes it. This is not encryption, this is just encoding. And it generates a blob. And so here is the blob it generates. And if you see this blob over the network, you can basically echo it, pipe it to base64 decode, and you see that this is admin, username and password. So this is completely in the clear. So if someone successfully logs in with basic auth, and you're on the same network, you can also log in with basic auth. Okay, let's quickly move beyond that, but you will actually need that knowledge in one of the levels. The next thing I want to talk about, typically you would do authentication using HTTP and HTML and your web application programming language. And this is typically done with a form submission. So there are two ways of doing authentication using forms. There is the awful way, which I'm going to show you first, and the traditional way, which is the way you should do it. The first way is via GET. So I mentioned that GET typically pulls content from the server. Well, you can actually specify parameters in the GET request that basically have the same functionality as sending the server data. So that's one form. That's a bad pun. But that's one way of doing authentication. So the problem with authenticating using GET is that the URL that you send to the server, that shows up in your browser history. right? And if someone pokes through your browser history, you're like, oh, look, username, password for that site. So you should never use get for your authentication, for authenticating your web application. So here's an example of what it looks like. Here is your HTML, and you specify that you want to create a form, which is what this UI looks like. You have two text boxes. One is a regular clear text box. One is a password text box, which will, dot out the password field. And then a submit. And when this submit happens, it will perform a GET request to the login.php. And so this is a PHP script that handles the login. And then what happens when you actually look at the request that goes over the wire, you can see that the get parameters, username is equal to admin. If I put admin and admin for the username and password, this is what gets sent by the browser. Username admin, password admin. It's taking these two input field names and it's attaching the two fields that you entered in. That goes over the clear. Well, if it's an HTTP session, you can see that. And then this whole path shows up in your browser history. Okay, so you should never do that. Typically, you would implement authentication using forms via a post. It's the exact same pop-up. You specify a post as your method. Same form, same submit. And then what happens is rather than using the get, you'll use a post to just that login URI. And then you'll see in the post payload, the username is admin and then the password is admin. Again, this is also in the clear, which is why this form submission should be done over HTTPS, not HTTP. But this is the mechanism in HTTP that sends the login form. Questions about form submissions? Yeah.
Is that something I could write like a console?
Up there? This is what shows up over the wire. If you want, you could type this in the console and log. Oh, right, yeah. So if you use netcat and you did this, this would also log you in. Yes, this is correct. Yep. Okay. So we can show you this on the homework site. You can see that the authentication is being done using a post, and you can actually view the form data submission that gets posted. This is actually important if you're trying to debug some of your cookie hacking. You will want to see, or your form in cookie hacking, you'll want to see the data in the request in the browser. If you have other kinds of software, like if you're using Burp or you're using Postman, you'll just have to navigate in their UI where the equivalent fields are stored. So Ponelandia, CS495, 595. If I submit that, and I go to the network requests, and I scroll up to... Why does it not want me to scroll up? Hang on a second. No, I have to log out again. Oh, I see the request I want, but it's not letting me. Where's that login? There it is. So if you go here, the request headers, the response headers, you see the form data. If you view the source, this is the raw form data, and it's just like I showed you earlier, where it's the login. The field is named login for the username, and then PWD for the password, and this is your form submission. Okay, So that's how you would navigate your developer tools to find what gets sent across. They parse this for you to make it easy for you to see. Okay. Don't think I'm going to get through this all today, but okay. I want to talk about something that's really important in web security and in web application security, and that is the way data is encoded. Any kind of injection attack at the heart has an encoding problem in it. You need the client and the server, when they're speaking this protocol, this HTTP protocol, there are a whole bunch of special characters in protocols. And if you actually want to send one of those characters as data versus control, you have to do some kind of encoding trick to tell the server that this is data, not something that's controlled. And so for that, there are specific encoding schemes that are used for the web. And I'm going to talk about specific ones, the URL encoding format, and then the HTML encoding format. We're first going to start with URL encoding. HTTP has some special characters. For example, the request lines are delimited by the new line, carriage return line feed, right? And the fields are delimited by spaces. Like I have a method, a path, and an HTTP version in that first request line, right? What happens if my path has a space in it? What happens there? How do I tell the server that that space is actually part of the URI and not the thing that's delimiting that field between that and the protocol version? So in order for you to send a path that has a space in it, you have to do this thing called URL encoding. And that's what this format is for. And in the case of the space, what happens is that there is a special character in the URL, the % character, and that says this is going to be an ASCII code, a hexadecimal ASCII code that you should interpret on the other side that way and then basically decode it as a space. So I'll send you %20 in the request, and you on the other side will turn that into a space. That's URL encoding. And you can see what happens. So here is oregonctf.org/x space plus space y. And if you click on that, you'll see an example of what URL encoding does. So I'm going to click on that, and you can see, well, you can't really see because, I don't know. No, I can't. Yeah, I can't make that thing bigger. Can I do the cell phone trick? No, my computer's not. Yeah, but you can see up here. Yeah, sorry. Yeah, I have a bad color scheme, and I haven't figured out how to. Oh, that's a good idea. And then, there you go. Thank you. So that's what you get. That's URL encoding. The other thing is HTML encoding, and this is important for things like cross-site scripting. So in HTML, it's structured with tags. So the less than, greater than characters specify tags, semantic tags within HTML. But what happens if I want to render a less than or a greater than? So as it turns out, for the HTML payload, you do something called HTML encoding. So in this case, if you want to render in your page a greater than symbol, you would do this. You would instead encode the and GT semicolon. Same thing with like the space. That's and NBSP semicolon, the less than, the ampersand itself. All of these things are encoded with these special names. But if you don't want to use these special names, or if a special name doesn't exist for the character that you want to show that's special, you can also use the actual hex code. So here you can use the and then the pound to specify a code that you're sending. And if you send 39, this is a decimal code that it interprets. But if you have and pound X, that means this is a hex ASCII code that you're sending to the other side. Okay? So if you're doing some kind of filtering, like you don't want people to be sending you these special characters, you should know about these encoding schemes. And in fact, we will run into these encoding schemes a little later in this course. Okay, are there questions about these two encoding schemes? These are the two main ones that we'll talk about. If you start building filters around these special characters, you will run into a problem where you need to be able to ensure that the thing gets decoded once and only once. So if I have encoded URLs and HTML on the client and sent it to the server, I have to make sure that there's only one place in the server that does the decoding. The problem is that you have no idea if some package that you imported is doing the decoding also, right? So double decoding is a security vulnerability, and it shows up. And this is why we talk about it. If you're trying to filter out all the equals, and you do a double decoding, well then something like this, if you double decode this thing, you'll get the equal sign back. So this is the assumption of who does the decoding and where it's done has to be known very precisely. So this is a forward reference to, there's a level in Natus, which I'm not having you do this class, but there are vulnerabilities that occur when you do this thing twice. Okay. The last thing about the client is that most of the requests now are moving over to the secure version of HTTP, HTTPS. And the most common misconfiguration is to not enable HTTPS. So on the previous site, I got it right on one site, but I got it wrong on the other. You can have a third-party site, you can point it to your domain, and it can test all of your stuff, and it will flag you. Like the Chini.com site got an F in terms of security because it doesn't have a certificate, it allows HTTP in the clear, it does all this other stuff that's bad, but it's only hosting static content, so that's okay. So with that, I got like 3 minutes. I'm going to have to finish the rest of this next class, and I'll talk about the web server then. Okay. If you haven't signed in, please sign in. Otherwise, I'll see you next class. Post on the Slack channel if you have any issues with that first homework, and we'll try and get you up and running quickly. Okay, so we almost finished the WebBasics. I got all the way up to the web server stuff, and I just want to briefly go through how typical web servers are configured. And then talk a little bit about web application frameworks, and this will segue into web programming languages. Because when you want to exploit a web application, typically it's written in a particular programming language, so we'll need to talk about those programming languages. Okay, so on the web server end, it's mostly Apache and Nginx. But Microsoft has their Internet Information Server software, which you might run into if you get a job at a Windows shop. I don't know much about that IIS stuff, so I'm just going to talk. It's probably pretty similar. The way it works is probably very similar to these other two. And typically, this is the piece of software that is hosting all of your assets, all of the files, the objects, the resources. They're stored on this server, and then that server's only job is to deliver that when it's been given a request. There's no typical directory structure on this server, but there will always be something known as either a document root or a root directory, and this is specified per domain that a web server is hosting. So it will typically map, the document root will map to the slash path, the top level path of a URI, of a website. And so some common ones, most of this stuff is on Linux. So some common paths are var-dub-dub HTML, var-dub-dub your domain that you're hosting /HTML. So if you have multiple domains, they would all be subdirectories of dub-dub-dub. /home/httpd is another common location. And so, for example, I host a site, it's chini.com, and I put the root directory. This is the directive in the config file. It says, put the root directory in var-dub-dub HTML/chini. And then what happens when someone accesses this URI, it goes to the document root/foo.html. It's a one-to-one mapping. And this is the way you can get these multiple sites to be hosted on a single web server. Okay, pretty simple. But my web server hosts multiple sites. So I run Nginx. And so I'm going to quickly peek into my Nginx configuration to show you what's going on. These configurations in Linux are in the /etc directory. That's where all the config for any of the services that you're running shows up. So in my case, it'll be etc nginx. And then there's a directory called sites available where I configure which sites my web server is going to host. And then within that, you'll see that there's multiple names. And so we'll just go and look through here. So this is in my sites available. I have 3 sites here, plus the default. So Chini is in one file, Mashimaro and the Feng. So I can look at this file, and you can see here the server name has been specified. These are the names of the host field. So we talked about HTTP. You supply the host field. If the host field has either one of these 2 names in it, then it'll get served from this config. And in this config, you'll see that the root directory is here, as I showed you in the previous slide. I also have specified a default file name for the index. So when you hit a URI that doesn't have a file name associated with it, it just like ends in a directory, then the default name of the file that the server tries to deliver back is specified here as the index, and in this case it's index.html. It's pretty standard. Let's see, what else is here? For this config, I say I actually want a regular web server on port 80 and an HTTPS server on 443. This is the secure version of my website. And in order to configure a secure version of your site, you need to set up some cryptographic information, which we won't talk about until later. Okay. So that's what I wanted to show you there. One of the things that I showed you last class was the automatic redirection of a port 80 into a 443. So when I hit thefengs.com on port 80, it gave me a 302. And that is also configured in Nginx. You say, hey, I've got this thing set up as a secure site. I don't want anyone to hit the regular domain. And that's set up here. If you see this, oh, I have it in less. Let me hang on. So this thing is programmatically saying if the host is this. So at the beginning, if I hit any server, if I hit any request on port 80, I am going to redirect the 301. Is going to redirect it to the secure version of this URI automatically. And this is how I make sure all of my users go to the 443. Okay. So that is a bit of server configuration. Are there any questions? This is important if you are managing a bunch of sites and you want to be able to make sure your requests are going to the right one. Yeah. It would so it would depend on what services you're using. If they are allowing you to manually set up Nginx, then you can specify a whole list of file sort of patterns that will be delivered. In fact, it could be a prioritized list. You could set it up to allow directory listings. In fact, I actually have that set up on some of my directories where I say, hey, if someone hits the thing without a file, just do a direct, this is insecure, very insecure if you're storing anything you actually want in that subdirectory, but Nginx and Apache will say, hey, there's a directive that says allow directory listings in the website. So there's a lot of configuration that can be done in these config files. You have to be able to lock that file down, which is not something we're going to cover a lot. We're sort of, so maybe this is the bad thing. We're not doing a lot of defense on this in this class. We're doing a lot of offense. But that is a defensive thing that you would need to do if you are running a bunch of web servers. You would need to make sure stuff like that doesn't happen, where you're like, no directory listings, specific files are only allowed. So, okay. Any other questions about this? Okay. Go back here. Okay, so the next thing I want to talk about are web applications. So it's rare that you're just going to be dealing with a static server like Apache and Nginx. It's often the case that these rich web applications are going to be implemented in some kind of programming, some sort of larger software base. And typically what you're going to deal with on a back end of a web application is a programming language environment, a template framework, and a back-end storage database. And these are all targets for an adversary to hit. And this is what we're going to cover next. We'll get to the back-end storage thing later on in this class. So we'll get to the programming language stuff in the next lecture, but the back-end database stuff, I'm going to just cover briefly here, and we'll get some exposure to it when we talk about injection attacks. But typically, these are the family jewels of any site, is the back-end database. And so you'll see that there are relational databases on the back end storing the information on the web app. So stuff like Postgres, MySQL, SQLite, Oracle, Microsoft SQL. There's also a prevalence of NoSQL databases, so these simple key value stores, so MongoDB, CouchDB. So you'll see a variety of these backends, and these backends must be secured along with the web application that's also mediating the access to that. So we'll talk about both of these. But I just wanted to pop that up there because this is the direction that we're going to go after this. Okay, so that is all I have on the web servers.